Electrical circuits. So today we're going to discuss electrical circuits. In an electrical circuit, there is a pathway for the current to flow. This allows the charge, electrical energy, to flow around the circuit. It has to be complete, without any breaks, and then you'll get current. But if it's incomplete with a break, there will be no current. So we have an example here of an electrical circuit. Now the symbols we'll learn a bit later, but we have here a cell which provides our electrical energy. We have our wires that the current will flow through, and then we have a light bulb here. So when we turn on the circuit, this is a complete circuit. The current will flow through the light bulb, and the light bulb will glow. But if we end up having a break in the circuit, let's cut a little bit out. This stops the flow of the current, and our light bulb will stop glowing. So the important things involved with this diagram and circuits in general is current, voltage, and charge. These will be discussed in a different lesson. There are two types of circuits. This first one we see here, this is called a series circuit. So there's a single pathway. So all the current will flow through that pathway. Any component will be put in a row along this single pathway. The second type is this one, which is a parallel. This has multiple pathways. So components can be on any one or more of these pathways, and the current will flow through all possible pathways. The amount of current is dependent on the resistance, which we'll discuss later. But the very important thing is, if you get a break in one pathway in a parallel, that will only stop that pathway. It will not stop the flow of current completely. Just everything else will just carry on going through any other available pathway that does not have a break in it. Whereas a single break in a series will stop the flow of current completely. That's why most household lights are using a parallel circuit, because when you turn off the light switch in one room, you don't want all your lights to go off, you just want the lights in that room to go off. And this means that it's much more useful and much more control. So we've seen light bulb and we've seen cell, but there are many different components you need to learn, and here are a few of the main ones. Well, the first one we know is cell. The second one is a battery. So a battery or a cell can be the power source that provides the electrical energy for your circuit. 9 times out of 10 we use a cell because it's easier, and it can also represent a power pack, power source in that respect. Now, a circle with an A in it is a very important device. This is called an ammeter. The ammeter can measure current, and ammeters are always put in series within the circuit, so the current will flow through it and it will measure how much that current is. A circle with a V in it is a voltmeter. This will measure the voltage used by a given component, so it's put in parallel over that component. It measures the voltage before the component and the voltage after the component, and then will display the difference. And so that will be the voltage basically consumed by that component. As we said before, an X in a circle is a light bulb. Very common and useful component to display if your circuit's working or not. And then a rectangle. This is a resistor. This can add a specific amount of resistance to a pathway, which will be very important when we start talking about things like parallel pathways and the flow of current. But if you get a triangle with an arrow for it, this is a variable resistor. Very useful in comparing how resistance changes and how that affects voltage and current. And probably one of the more important ones are the switches. So this is an open switch. So when switches are open, they break the circuit, and so current will not flow. And when they are closed, current will be able to flow. So next time we will talk about the idea of series circuits in more detail, and then parallel circuits in more detail.